So this is the math dealer here, and welcome back. So this video is part 3 of a 5-part series, okay? And this is all about the polynomial unit test review, okay? A little shout out to my little Algebra 2 students out there. All right, I'm really hoping this is helpful. I know this whole virtual thing is crazy, but hey, good thing is in the classroom, you can't pause me. But on a video, yep, you can. All right, so this is probably the biggest part of this whole unit, right? Is when you're actually given a polynomial and you're trying to find all the zeros. So what we talked about before is the P's and Q's, okay? So basically we're going to look at factors of your last term and factors of your first term, okay? So like I said, this is a review video. If you're not sure how to do any of this, go back and watch my video that like walks you through all those steps that I wrote out, okay? So basically our possible rational roots deal with factors of the last term over factors of your leading coefficient. Well, the fun thing is the only factors here are 60. So plus or minus 1, plus or minus 2, plus or minus 3. Oh my God, this is going to go on forever. Basically, all of these are factors of 60. I know, crazy. Wow, I really hope we can find a way to make this go a little bit faster. I know, right? Okay. And what am I at? 30 and then a 60. Woo, that was a lot of factors, okay? So the first thing you're going to do is check to see, does 1 work, okay? If you add up all those coefficients, unfortunately, guys, 1 doesn't work because those coefficients do not add to 0. Remember what I said in class. If those coefficients add to 0, then you know 1 was a root, okay? So 1's not a root, all right? So then maybe you're saying, you know what? Well, let me try 2, okay? Let's just try 2. So 2 is going to come in. Write down the leading all the coefficients, excuse me. 1, 1, negative 13. Make sure we're not missing a term because, you know, sometimes I lose a term there. All right, here we go. We drop, we run, we drop, we run, we drop, we run, we drop, we run. I had to think about that one for a minute. We drop, and that gives me what, 30? Ah, yes, check that out. Negative 60. Oh my goodness gracious. We actually found the root the first time through. Awesome, right? Problem is that now I have x to the fourth, 3x cubed, minus 7x squared, plus 9x minus 30. And that doesn't really lend itself nicely to something that I can factor. So now I have to depress again, meaning I have to go back to my root list and try another value. Try another number, okay, from my possible rational root list, okay? So I have a 1, a 3, a negative 7, a 9, and negative 30, okay? So when I go through and I'm saying, okay, I need to try this out, sorry about that, right? Maybe I might try a 3. So if I try a 3, I drop, I run, I drop, I run, I'm dropping, what's that give me? Like 11 gives me 33. Yeah, this ain't gonna happen, right? There's no way I'm gonna get over here to a 15. So this, 15 to 10, so I can cancel that out. So 3 doesn't work. So remember, go back. I have 1, 3, negative 7, 9, and negative 30. So I keep using these coefficients. I don't go back to the original coefficients because I've already depressed it to these coefficients. And that's where this one came from. Okay, so now let's pick another one. Okay, I think I might try, like, I don't know, negative 5. Let's see if that works. Drop it, run it, drop it, run it, drop it, run it. And when I do that, I get 9 minus 15, which I'm pretty sure is like negative 6. Oh my goodness gracious. Praise the Lord. I found another root. Okay. All right. So that's going to leave me with an x cubed minus a 2x squared plus 3x minus 6, right? Because now these are the coefficients of my new depressed equation. Remember, the depressed equation came from a degree of 4. So, of course, I had to have a degree of 3. Now, this is that factoring by grouping thing, right? So if I factor out an x squared, I'm left with x minus 2. That's exciting. Over here, if I factor out a 3, I'm left with an x minus 2. Again, pulse is racing, super excited. Notice I threw it as equal to 0 because don't forget, we are solving for the roots. So I'm going to factor out an x minus 2. I'm left with x squared plus 3. And like I said, if the factoring one's a little fuzzy, go back and watch that video. That's the beauty of these videos. They're there for life. Okay, x squared plus 3. Then I get x is equal to 2. Over here, when I bring the 3 over, I get x squared is equal to negative 3. Lo and behold, x equal to plus or minus, yep, you guessed it, the square root of negative 3, which is plus or minus I. All right, so check this out. I have quite a few roots here, don't I? Okay, I'm going to write my roots up here. So nice, lots of roots. So I have one root is 2, right? That came from here, okay? Another root was negative 5. That came from there. Another set of roots was plus or minus I square roots of 3. And another root was 2. Well, I already have a 2. So what I can say is that that 2 was actually a double root, meaning it happened twice. Okay? Meaning it happened twice. Now, if I was going to ask you to write this in factored form, okay, if I was going to ask you to write this in factored form, here, let me slide this guy out of here. Okay, you can do it. It's not like you can't, but not that way. Okay, so to write this in factored form, sorry about that. Slide this there. Okay, to factored form, I have a 2 that happens twice. So that's going to be x minus 2 squared, because it happens twice. I have a negative 5 that happens once. That's x plus 5. And then, of course, I do have plus or minus I radical 3, right? Which you know came from this right here. So that's how I would factor it. X squared plus 2. Okay? So if I wanted it in factored form, this is what it would look like. Notice, since x minus 2 was a factor twice, I write it with a degree of 2. I really hope that makes sense. Okay? If not, I don't know, rewind. Maybe that might help. But just remember, if it's a double root, it's a double root. That means it occurs twice. Okay. Oh, we don't want to do part 4 yet. That's crazy, crazy, crazy. Okay. So let's go look at this next one I have up there. I know it's been kind of clicked over with that, but that's all right. Here we go. I have 3x cubed plus 2x squared minus 7x plus 2. And again, you're trying to find all the roots. So here we go. First thing, P's and Q's. The factors of your 2 is plus or minus 1, plus or minus 2. Factors of your leading coefficients are 1 and 3. Okay? So when I do my list of possible rational roots, okay, basically I'm taking 1 over 1 and 1 over 3. Okay? And I'm going to write that down. Plus or minus 1 over 1 plus or minus 1 over 3. Then I take 2 over 1 and 2 over 3. Okay? So then I go plus or minus 2 over 1 plus or minus 2 over 3. And that's how I get the list of possible rational roots. Basically, think about it like this. This, over that, over that, and over that. It's the tops over the bottoms. Okay? So now what I need to do is, okay, now I just need to go figure out, well, do I have a root here? Remember, if 1 is a root, then all of these numbers would sum to 0. 3 plus 2 is 5. 5 minus 7 is negative 2. Negative 2 plus 2, yeah, is 0. So use that. 1 is a root. I have a 3, a 2, negative 7, and a 2. We drop, we run, we drop, we run, we drop, we run. Woohoo! Super, super excited, right? Because I knew 1 was a root, meaning I depressed my equation. Now I have a new equation. 3x squared plus 5x minus 2. Set that equal to 0, and guess what? You can factor this one. And that's really what your mission is. You're trying to get it so you could factor to find the remaining roots. Because you know if I can get it into a quadratic, I can use the quadratic formula, or I can complete the square, or I can factor. Factoring, if it's possible, do that, because that's really probably the easiest. If it's not so easy for you, run the formula. I'm not going to cry. Okay, so which means my other two roots, set them equal to 0, and solve. Slide the 1 over, gives me 1/3. Slide the 2 over, Merry Christmas. All right, so here are my roots. Dun, 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 dun. You knew I was going to have 3 roots. One of them was a 1, 1/3, negative 2. And that's it. Done. Call it a day. All right, so like I said, this was part 3 of a 5-part series. I hope you tune into the next one for part 4.